My dear students, this time we are going to learn decision making under risk. So there are two prescribed criteria, EMV and EOL. We can take decision by any one of these criteria. The answer will be the same that we will see later after doing some examples. So EMV is expected monetary value and EOL is expected opportunity loss. Now, first understand that how decision making under risk is different situation from decision making under uncertainty. This we have discussed earlier, but here let us have a quick recap. In decision making under risk, probabilities of occurring of each states of nature is given. It is provided to you that probability of each states of nature, and then this is the difference. Here you are one more information will be supplied to you, that is probability of occurrence of each states of nature. That is the one more information, additional information that is available in the case of decision making under risk. So here there are two criteria we are going to use, EMV expected monetary value and EOL expected opportunity loss. EMV, first we will take EMV criteria. So it is similar as we have seen in the case of Laplace criteria in the case of decision making under uncertainty. There what we used to do, uh, there we assumed that probability of each states of nature is equal, and once we assign equal probabilities to each states of nature, then we calculate EMV for each course of action. Then we calculate EMV for each course of action. For what, how we calculate? First we multiply probability with each payoff, then it becomes expected payoff, and then we add all the expected payoff along each course of action, and that summated payoff is known as expected monetary value. And that among all the expected monetary value, the criteria the course of action corresponding to maximum EMV is taken as decision. The similar thing we are going to do here. The only difference is that in the case of Laplace, we have to assume that probability of each states of nature is equal, and here we need not to assume. We will be given probability. We will be given different probabilities for each states of nature. Only this is the difference. Now, see the question of we will see the question of the form which is generally asked. So generally this is the style of, this is the language of question, type of question which you will generally see in the case of decision making under risk. So just I have taken one example, and this is the question. I will read slowly and slowly. If you want to note down, I'd suggest you to note down, because that will be helpful you to understand when I explain the solution. Now I'm reading slowly. Under an employment promotion program, under an employment promotion program, it is proposed to allow sale of newspapers on buses during off peak hour. The vendor can purchase the papers at a special concessional rate of 25 paise and sell it and sell it and sell it it will be and sell it and sell it for 40 paise per piece, and sell it for 40 paise per piece, full stop. Any unsold copy is a dead loss. Loss means complete loss. You are going to waste all the money which you have invested in purchasing. Any unsold copy is a dead loss. The vendor has estimated the following probabilities for the number of copies demanded. A number of copies in one row and probability in another row. Number of copies 15, probability is 0.04. For number of copies 16, probability is a 0.01, 0.19, sorry. Probability for 16, probability is 0.19. For 17, probability is 0.33. For 18, probability is 0.26. For 19, probability is 0.11. For 20, probability is 0.07. Prepare a payoff table and find out how many copies should be ordered so that his expected profit will be a maximum. So that his expected profit will be a maximum. Now again, just this time I will read it fast. Under an employment promotion program, it is proposed to allow sale of newspapers on buses during off-peak hour. The vendor can purchase the papers at a special concessional rate of 25 paise and sell it for 40 paise per piece. Any unsold copy is a dead loss. The vendor has estimated the following probabilities for the number of copies demanded. Now this is the probability. Number of copies 15.04, 16.19, 17.33, 18.26, 19.11, 20.07. Prepare a payoff table and find out how many copies should be ordered so that his expected profits will be a maximum. Now understand the question. The question says that uh, in a particular sales program, employment promotion program, one newspaper is bought at 25 paise and it is sold at 40 paise. And if any copies remain unsold, then that will be the loss, because one newspaper is not sold on that day, so for next day it becomes valueless, so it is not, it will be destroyed, so you can say it is a dead loss. So now this is the uh, based on some observation, this data is collected, and this data shows that uh, demand for 15 copies, demand for 16 copies, demand for 17 copies, demand for 18, and demand for 19, and demand for 20, and demand for 15 copies will have this probability. So these are the probabilities for different demands. So these demands are the states of nature, कि 15 का डिमांड आ सकता है, 16 का डिमांड आ सकता है, 17 का डिमांड आ सकता है. दिस इज नॉट फिक्स्ड दैट व्हाट टाइप ऑफ डिमांड विल कम. Now the question is that you have to take this decision कि how much stock, how much newspapers that person, that how many newspapers should be purchased. दिस विल बी द कोर्स ऑफ एक्शन कि 15 परचेज करे कि 16 परचेज करे कि 17, 18, 19 या 20. So in the anticipation of these demand, course of action will be decided. So now here you have to take decision that how many newspapers should be bought. 15, 16, 17, 18, 19 or 20. Here, since the probability of each states of nature is given, so we can use any of the criteria, EMV or EOL. So first, and when it is very interesting to know that from both criteria we will get the same answer. So this question we will do with the with with the help of both the criteria, EMV and EOL. So first we will do with the help of EMV. So here you have to make a first you have to make a payoff table, because you don't have payoff table here. So now very interesting to see that how we are going to write payoffs for each course of action and states of nature combination. So here I suggest you, the first thing is that here we will adopt the format. In this time we will write states of nature this side, states of nature this side, and this side we will write course of action. Why? Because if we write in this format, so calculations will become easy and presentation becomes easy. Otherwise there is no such hard and fast rule that there is no such compulsion. But if you adopt this format of writing, that will become helpful to you in this case. So now what are the course of action? First he can stock 15. फर्स्ट 15 की डिमांड आ सकता है, 16 का डिमांड आ सकता है, 17 का, 18 का एंड 19 का एंड 20 का. Then we will write probabilities. Here probability is 0.04, here probability is 0.19, here probability is 0.33, here probability is 0.26, here probability is 0.11, here probability is 0.07. Now we are going to write course of action. This is the data which has been given in question, so I have just written in this format, states of nature this side, and then along with the probabilities. Now course of action will be decided in the anticipation of these demands. So either he can stock 15 newspapers, or he can stock 16, or he can stock 17, or he can stock 18, or he can stock 19, or he can stock 20. So these are the course of action: 15, 16, 17, 18, 19 and 20. Now we will calculate payoff for each. We will write payoff here. So now see, if one newspaper is purchased, so what is the cost price of one newspaper? Right here. Cost price of one newspaper, that is 25. And what is selling price of one newspaper? That is 40. So profit after selling one newspaper will be 40 minus 25, that will be 15. Now see, if he maintains a stock of 15 and demand of 15 comes, so all 15 newspaper will be sold out. So after selling 15 newspaper, what will be the profit? What will be the payoff? So after selling one newspaper, he is getting profit of 15 paise. So after selling 15 newspapers, he will be getting 15 into 15. So that will be 225. 15 into 15 is 225. Now if he maintains the stock of 15 and demand of 16 comes, so there will be no issue, because demand of 16 means that all the 15 newspaper will be sold out. So all the 15 newspapers will be sold out, so he'll be getting profit of 225. In the same way, in the case of 16, if he maintains the stock of 15 and demand of 17 comes, so all the 15 newspapers will be sold out. So you can say in each case it will be 225. Now here, if in this case, see, if he maintains the stock of 16 and demand of 15 comes, so what will happen? 15 newspapers will be sold out, and one will remain unsold. So if 15 newspapers are, just see the calculation I am doing here. If 15 newspapers are sold out, then what will be the profit? 225. Now one newspaper remained unsold, and that is the dead loss. So how much loss he is going to make here? These 25, because one paper is purchased for 25, so 25 rupees will be loss. So now what will be the profit? 225 minus 25, so it will be 200. So now it will be 200. In the same way, now he maintains the stock of 16 and demand of 16 comes, it will be 16 into 15. 16 into 15 will be 240. Now if he maintains the stock of 16, demand of 17 will come. So again you can see all the 16 newspapers sold. Here it will be 240, here it will be 240, and here it will be 240. Now see here, if he maintains the stock of 17 and demand of 15 comes, so what will happen? All the 15 newspaper will be sold out. So after selling 15 newspapers, he will get 225. And now how many newspapers remained unsold? Two newspaper. So two newspaper ka cost हुआ 50 paise. So this 50 paise will be the loss. So it will become, I think, 175. So here it will be 175. Here it will be now 17. In 17, 16 are sold out. So of profit after selling 16, it will be 240, and one remained unsold. So 240 minus 25, it will be 215. So in this way you can see here 17, if he maintains the stock of 17 and 17 is the demand, so all the 17 newspapers will be sold out. So it will be 255. So 17 into 15 will be 255. In the same way, here all the 17 newspapers sold out, here all the 17 newspapers sold. So if you calculate in the same way, because I have calculated earlier, so I'm just writing. If do all the calculation by yourself, if you find any difficulty, then ask me. So it will be 150, just in the same way, with the same logic. 150, it will be 190, it will be 230, it will be 270, it will be 270, it will be 270, and here 125 and 165, here 205, here 245, here 285, here 285, here it will be 100, here it will be 140, here it will be 180, here it will be 220, here it will be 260, and here it will be 300. So now see, just do by yourself, and after that just check the calculation. Right. So this is what, this is because here we have written payoff by putting the condition if demand of 15 comes and the course of action is 15. This is the reason, by putting condition we have calculated payoff. So this table is known as conditional payoff table. Conditional payoff table. This is conditional payoff table. Right. Now what we will do, now see what we are going to do. This time we multiply this probability with this and this and this and this and this, the same way this probability with this and this. So for example, 0.33 into 225, 0.33 into 240, 0.33 into 55. So all the probabilities will be multiplied along each states of nature with all the payoffs. And when we multiply probability, so it becomes expected payoff. So now we are going to write expected payoff table. After conditional payoff table, we are going to write expected payoff table. So I'm just directly writing expected payoff table because I have done calculation earlier. So now it will be 15, 16, 17, 18, 19 and 20. 15, 16, 17, 18, 19 and 20. It will be 9. It comes out to 42.75. It comes out to be 74.25. It comes out to be 58.50. It comes out to be 24.75. It comes out to be 15.75. The same way here, 8, 45.60. Then here 79.20. Then here 62.40. Then here 26.40. Then 16.80. Then here 7, 40.85. Then it is 84.15. Then here 66.30. Then 28.05. Then 17.85. Here it is 6. Here it is 36.10. Here it is 75.90. Here it is 70.20. Here it is 29.70. Here it is 18.90. Here it is 5. Then here it is 31.35. Then here 67.65. Then here 63.70. Then here 31.35. Then here 19.95. And here 4, 26.60, 59.40, then 57.20, then 28.60, then 21, then 21.0. So what we have done, we have just multiplied probability with each payoff. Now we are going to add these payoff along the course of action. This we have done in the case of Laplace criteria also. We are going to add these payoffs. So just see the summation, and these are known as EMV. So here it is 225. Here it is 238.0. Here it is 244.20. Here it is 236.8. Here 219. And here 196.80. Just listen, because these are the EMVs, and if you are reaching here correctly, it means that all the calculations which you have done midway are correct. So first EMV is 225, second EMV is 238.40, third EMV is 244.20, and fourth EMV is 236.8, and then next 219, and then 196.80. Now the maximum EMV among all these EMVs, this is the maximum. So this is the answer. So this is corresponding to 17. So according to, or you can write answer, stock of, or stock of 17 is maintained, or 17 newspaper is purchased. or 17 newspaper is purchased, whatever you want to write is 17 newspaper should be purchased. So I think it is clear to you. If you find any difficulty, because we will take one more example, so just I suggest you to just see this video twice, at least twice. Okay.